Here we go, calculus cone heads. We're going to do example 5, higher derivatives and concavity. So we have a function here. I don't think I'm going to keep the voice up. All right, so we have a function here. Of course, we find the increase, decrease, max, min from the first derivative. So we take the first derivative here, f prime of x. That's going to give us 12x cubed minus 12x squared minus 24x. And then that goes away, right? Okay. So then we set that equal to 0. And this is going to just lead to, I don't know, what do you guys think? Just algebra. All right. We can factor out 12x. And that leaves x squared minus x minus 2. And then this factors even further. I hope. If it doesn't, we can do the quadratic formula. But hey, look, the guy that made up the question was pretty nice. Wasn't he or she? So then if you set each of these equal to 0, we get 0 from this one, we get 2 from this one, and we get negative 1 from this one. 3 critical numbers. That's just algebra. There's no division by 0 potential on this one. So once again, we don't need to worry about that. Okay, so time to do the first derivative test. And so our number line that's ultimately going to represent the x-axis on a graph will have those 3 numbers on it. And I always like to document the fact that the first derivative is 0 at those 3 places. And so at the end, when we graph it, there should be some horizontal tangent lines at those 3 places, shouldn't there? All right, so let's get the just algebra out of the way. Is it important to know algebra here? Yes, it is imperative. So, testing numbers in the first derivative, how about negative 10? This gives you some good arithmetic. Let's see, negative 10 to the third power would be negative 1,000 times 12, that's negative 12,000. And then negative 10 squared is 100 times that, that'd be minus 1,200. And then negative times negative, that'd be plus 240. And I can tell already that that's all going to be a negative number. So that first derivative is negative in that interval. So it's decreasing from negative infinity to negative 1. And we'll put that in the decrease box. Increase, decrease, max, min, first derivative. That was a previous assignment, okay? Oh my gosh, negative a half. I guess we're stuck with that one. Oh boy, this is gonna make my brain hurt. Let's see, negative a half to the third power, it's gonna be negative, that'd be negative 1/8, and negative 1/8 times 12 would be negative 12/8, and that'd be negative 1.5. I hope my math is good here. Negative a half squared is positive 1/4. So then negative 12 times positive 1/4. Negative 12 times positive 1/4 would be negative 3. And then negative a half times that, that'd be plus 12. And that's just arithmetic. If I screwed up there, oh boy. So anyway, I think we're doing that in there. And so it's increasing from negative 1 to 0. These are intervals, not to be confused with ordered pairs. F prime of 1, oh good, I think I can do that one. Okay, let's see, put 1 into the derivative. 1 cubed is 1 times 12, that'd be 12. I really didn't do a very good job of making space here. I don't have a lot of board space, okay? 1 squared 1, that'd be minus 12. And then negative 24 times 1 would be negative 24. Do the math on that, the arithmetic, and I think that's going to be negative. So, negatively sloped tangent lines, indicative of decrease from 0 to 2. Alrighty. And then f prime of 10, that's out there, isn't it? Okay. Let's see, 10 cubed. You're welcome! 10 cubed is 1,000 times 12, that'd be 12,000. 10 squared is 100, right? So that'd be minus 1,200. That could be be working these in columns, I guess. And negative 24 times 10 is negative 240, and that's all going to come out to be positive. So, you know, again, we have that alternating pattern, but I always tell people don't depend on that. Down, up, down, up. All right, so wouldn't it be increasing from 2 to infinity? All right, so that's what that picture hopefully see, you know, down, up, that kind of thing. You know, and again, at its most basic element, I would say that graphing is plotting points. And the important points, so important that some people even call them critical points, is to put these into the function, right? So, negative 1 to the 4th power is 1 times 3. That'd be 3. Negative 1 cubed is negative 1 times that. That'd be plus 4. And then negative 1 squared is 1. That'd be minus 12. So, it looks like that's going to be negative 5. I hope this is all good. So, what do we got? We got decrease coming in, increase going out. Wouldn't that be a minimum? So the ordered pair negative 1, negative 5 is going to end up being a point on our graph. It's going to be more specifically a minimum point. All right. Then we put 0 in there in the function. Yes, I can do that. 0, 0, 0. Did I put this in the right one? Yeah. Okay. 0, 0, 0. That'd be 0. What's that? Up, down. What do we got? That's a decrease, or that's a max. Pardon me. So, hello, max. 0, 0. Okay. And then 2. Let's put that in there. 2 to the 4th power is 16. And 16 times 3 is 48. 2 cubed is 8 times negative 4. That'd be minus 32. This is arithmetic, isn't it? 2 squared is 4, minus 48. And I think that's going to be negative 32 there. And wouldn't that be a minimum? So, 2 comma negative 32, minimum. First derivative. Been there, done that. All right? Increase, decrease, max, min, first derivative. All righty. Hit pause whenever you want. You erased that too fast. Go back. Hit pause. Okay? So this is maybe in some ways helps you catch up a little bit as opposed to class when I go too fast. Okay, f double prime of x. 36x squared minus 24x minus 24. Second derivative. We're about to perform what they call the second derivative test. Okay? And, okay, undefined, and I'm not giving you many of those. In fact, none of them so far, but that's okay. So 36x squared minus 24x minus 24 equals 0. Just the algebra. Factor out of 12. That gives 3x squared minus 2x minus 2. I'm not so sure that that's going to factor. So what does a person do when it won't factor? They do the quadratic formula. All right. First of all, the 12 isn't going to give us a 0. So I'm guessing that we need to do the quadratic formula on that one. And so look, it is just algebra. And so if we do the quadratic formula on that trinomial there, QF, quadratic formula, yeah, you might have to. QF, quadratic formula, x will be approximately negative 0.55, as well as x is approximately 1.22. That'll work. Okay? So, we've got what I would call potential inflection points. And we're about to perform what the math nerds call the second derivative test. All right, so here's x, here's f double prime of x. And these are places where the second derivative is indeed equal to 0. F double prime of negative 10. And I'm going to do negative 1. That's out there. That'll be easier. All right. Negative 1, f double prime. Negative 1 squared is 1 times 36. That'd be 36. Negative 24 times negative 1 is plus 24. And then minus 24. That's all going to be a positive number. concave up. So, from negative infinity to negative 0.55, it's concave up. All right, let's do f double prime of 0. That's in here. That's easy. 0, 0, negative 24, emphasis on negative. Negative, all right. So, concave down. So concave down from negative 0.55 to 1.22-ish. Those are rounded. Being a little sloppy, I get it. Get over it. All right, and then f double prime of 10. Let's see. 10 squared is 100 times 36. That'd be 3,600. Negative 24 times 10, negative 240. And minus 24. You can tell that's going to be positive. Whoops, concave up. All right, positive. I like green for up, blue for down. Doesn't matter, you can't probably tell the colors anyway. But this is concave up again from 1.22 to infinity. All right, so there we've got that one. And once again, this is example 5. So, one more thing. Let's find the points that are associated with these. And so, don't we put those into the function, negative 0.55, comma, put it in the function. All right, and the same for 1.22. Put it in the function. So negative 0.55, put it into the function. Oh boy, let's see, 3 parentheses 0.55, negative 0.55 to the 4th power, minus 4 parentheses, negative 0.55 parentheses raised to the 3rd power, minus 12 parentheses 0.55 squared, minus 1. Let me look at this one more time. Makes me nervous that you're not here when I mess up to fix things, but I think negative 3.69 we'll call it. And the concavity changed, so that is an inflection point, and that will go here. And this will be another point that we'll put on our graph. Negative 0.55, negative 3.69 would be a point. And it's an inflection. By the way, the other one's going to be 2 because the concavity changed. 1.22, all right? 3 times 1.22 to the 4th power minus 4 times 1.22. I probably should have kept more digits on those. I'll be the first to acknowledge that. Anyway, putting that in here, let me take a look again. 3 times number 4th power minus 4, number to the 3rd, minus 12, number squared, minus 1. I hope it's right. I keep my fingers crossed. If I discover this is wrong later, apologies. I'm probably not going to come back and re-record the whole thing if that's wrong. So 1.22 and then that number, 1.22 and negative 1948. 1948. It was a great year. Yeah. That was the year I graduated college. Please laugh. Okay, so let's put all that information together to build us a beautiful graph on that wonderful graph paper that Mr. I'm sorry, my brain is kind of getting squeezed here a little bit here. Mr. Chicken Salad Sandwich, that wasn't very good. Anyway, we're going to put all that together to build a graph here. Be thinking about the scale that you think we should use here based on the ordered pairs that we've discovered. All right. I'm thinking on the X, it looks like 1s would be pretty good here. Although we could spread it out a little bit and make it 0.5. let's take a look at that. Yeah, you know what? I'm gonna do that. I think I'm gonna make the X scale be 0.5, whereby then every 2 boxes is a 1, right? You can do whatever you want there. There's no right or wrong. The main thing is whatever scale you use, please identify it for us and then use it, obviously. So, then the Y values, they're kind of all over the map. 32, you know. I guess 5s, that'll work. I hope it'll work. So Y scale 5. All right. 5, 10, 15, 20, 25, 30. 5, 10, 15, 20. Let's start plotting some points. We've got 0, 0. All right, that's easy. We've got -1, -5. Here's -1, -5. Remember, I chose to plot the y-axis, scale the y-axis by 5s. All right. 2, -32. 5, 10, 15, 20, 25, 30, somewhere down in here roughly. All right. And so we've got that. And I think that would work there. Okay. And then we've got these inflection points, -0.5-ish, -3-ish. So -0.5, -3, somewhere right in there. And then we've got 1.22, -20-ish. 1.2-ish, -5, 10, 15, 20-ish. So, decrease, increase, decrease, increase. I'm looking at the first derivative. Decrease, hit the inflection point, increase. Decrease, hit the inflection point, increase. So there again, we've got these points where the tangent line was horizontal. That would be these maxes and mins here, where the first derivative was 0. And then we've got these 2 points that it's really hard to tell when you just look at a graph, but that would be where the curvature changed. So again, we had upward concavity here, and then in this area, it was downward between these 2 points, and then it became back upward again. So anyway, that's the best I could do on that, and I'm excited to say that we're about to have the world premiere of okay. Sorry, I gotta get this ready here. Sorry, I'm excited. Okay, so, ladies and gentlemen, we're about to have the world premiere. You are a deriver. I am a deriver. We're all derivers. Let's start that again. Ladies and gentlemen, I'd like to introduce the world premiere. You're a deriver. I'm a deriver. Here we go.